I didn't get a chance to see who was in the room, but so the topic tonight is two queen systems. And I'm going to make a distinction as we go along between two queens and multiple queens. And it's because it's a little bit different. I want to start by trying to prove to you, beekeeping skeptics as I am, that it's possible to have two queens in one colony. And there's the sword in hand of, you have two queens. So this is the principles and practices of multiple queen management. And I'll start off by giving you a little history of Hymenoptera and the possibility, and try to explain the possibility that multiple queen examples exist in Hymenoptera, which of course are sawflies, wasps, bees. Honeybees is what we particularly are interested in, bumblebees, of course, and ants. And so since they belong to the same order, there's many examples in Hymenoptera where there are multiple queens. One is fire ants. Fire ants are down south in our area in North America, and and they can have about 25 queens per colony. So they exist pretty much in harmony, and queens are not fighting for dominance, and there's no sense with fire ants that there's going to be a winning queen. All right, so if we can look at some more examples. So that's one part of Hymenoptera where multiple queens are just common. Right? The other one is paper wasps. Now, of course, paper wasps have multiple foundress queens. Now, this is the same paper wasp that you see all summer around in those little nests. They have multiple foundress queens. The interesting part about the way that paper wasps and all wasps, if they have multiple queens, deal with it is some become subordinate, and it's based on their facial coloration. So this is a wasp, but it's not a paper wasp, but I just wanted to put it on there so you could see the distinction in their face. They have these extraordinary markings on their face, and the queens stare each other down, and the facial coloration is one criteria where they select the absolute queen that's going to take over the colony. But all the rest of them remain fertile, and they can all assume egg laying at any time. And as usual, since you're going to have this taped and available to you, all of those, you're going to see all of these citations on the bottom are there for your benefit to go back and look at and read more about any of the subjects that I present on these slides. Some other examples are big-headed ants, and I've never seen any of these. But they're supposed to be the world's worst invaders. They're down in Florida. Like I said, I haven't seen any of them. But again, here's another example of Hymenoptera where there's multiple queens, and they live in harmony, and there's a massive quantities of ants in these colonies, hundreds and hundreds of thousands. And the reason that's possible is because they have multiple queens. So the next example is the southern yellow jacket. Now this gets closer to home. You can see these queens are these are dominant queens. Both of them, these are egg-laying queens, and they continue to lay eggs. There's no dominant queen that takes over. There's no subordinate queen. They just continue to lay and lay and lay. So southern yellow jacket colonies get very big because they can lay eggs all year round. In our case, up here in the Northeast and where it's a little bit cooler, we only have single queen colonies as yellow jackets. But you can see how sort of pliable Hymenoptera is with multiple queens. So here's the southern yellow jacket. They have multiple queens. The northern yellow jacket, they just have one. Right? So it's an interesting sort of evolutionary trait. And a little bit closer to home is the bumblebee. And bumblebees, of course, this happens to all bumblebees. They oscillate between a single and multiple queen nesting cycles. So what happens with bumblebees is a foundress queen comes out of the ground in the spring. And by the way, I collect them when I can, and I put them in little boxes, and I run bumblebee colonies all year. They're fascinating to do. You just grab a queen, put it in this little box I make, and in that little box I have old mouse nests, which are a favorite for bumblebees, and you can get them to grow a nice little colony in there for you. So, but I digress a little bit. But they start off with a single foundress queen, and then they add queens as time goes on. But during that time when multiple queens exist in a bumblebee colony, there's a little bit of aggression shown toward each other. And then the nest oscillates back to a single queen. So for a period of time, they allow multiple queens, and then they oscillate back to a single queen. Those other queens are driven out of the colony, and they start their own colony. So that's how they basically split bumblebee colonies. So that's all happening, whether or not you realize it or not, right in your own backyard. Right, and so I have a little note down there that's sort of a natural version of some managed two queen systems, and I'll talk a little bit more about that as we get going. So then in this particular piece, I'm going to talk about how multiple queens in one colony for honeybees is not normally a good thing, and it can result in a fight for reproductive supremacy. So we all know, and we've heard it many times, the bee lore or the oral tradition of beekeeping is that your colony has one queen. That's not always true, by the way. And I'll give you some of Hoppengardner's work later on as we talk more about that. But multiple queens can live in a colony if they can't fight or are separated in some way by a queen excluder or something. And other times when multiple queens will exist in a colony is during a strong honey flow, if you've gone through the manipulations to introduce two queens, and I'll discuss how that's done. Or if it's in a supersedure, and I'm sure some of you have seen supersedures where there's a mother and daughter queen. And I've seen them many where there's a marked queen and another queen on the same comb, even in a supersedure. Why in supersedure do they don't get into that fitness struggle? I don't know. But they sometimes let that mother queen last over winter, and she'll come into the spring also, and then eventually fade away and die. Now, in this fitness fight that queens have, they use their mandibles to hold each other's head steady, and then they probe with their abdomen and stinger to try to find a place between the little soft plates on what they refer to as the stergites on the bottom of the queen, each of them. So they're stergites, they're underbellies, right? Their abdominal part of their bee is facing each other. And so they probe in there until they can find that little soft spot. By the way, that's the same place that a varroa feeds on a regular bee, right? In those, they call them non-scrollerized area between the stergites on the bottom of a bee. And so they probe in there with their stinger until they can find a place to sting that other queen, and the one that stings first wins. Usually it's a virgin queen that wins a fitness contest between a mated queen and a virgin queen because their abdomens are more flexible. A mated queen has a stiffer abdomen because she has larger ovaries that have been developed. So and by the way, a virgin queen has a more potent venom than a laying queen, which is of course much older, and her venom sacs aren't as potent as a virgin queen. All right, so now the Chinese knew about this mandible head hold, and they use it to their advantage. And here you're going to see an example of how this is sort of an extreme manipulation where in this study here, This particular scientist, I'm not certain how to pronounce his name, but I've read a lot of his work, and he did a lot of work with multiple queen colonies for the benefit, financial benefit of the Chinese beekeeping industry. And so the ultimate configuration that he came to was to remove about 1/3 to 1/2 of the mandible on his queens. So that's a little tiny scissors, a little dissecting scissors, and you hold the queen and clip a little bit of her mandible. Now they called it a blade. It's called a bladement. It's just clipping, like you would clip wings. And if bees cannot engage in that mandible head hold, they cannot find dominance in a colony, and they function normally. There's no lethal contest. They work, and there's really productive colonies. Right? So, even in Apis mellifera, and this is ligustica, this is the Italian honeybee, so to speak. That's what we refer to it as. Currently, isn't a real Italian honeybee, because in the United States, all we have is bee stock, but we refer to them as Italians. And here you see, I think there's 5 circles there of queens on the same comb face. So they're really productive colonies. They use them when the Chinese people make lots of royal jelly, and they use these multiple queen colonies to produce lots of brood for other colonies, and so on and so forth. So we don't usually do this in the United States much, but it can be done. All right, so just to summarize, and hopefully I've made the point that Hymenoptera can have many different queen arrangements, some naturally in other species of Hymenoptera, and that in a honeybee colony, multiple queens can exist and often do. But the question that I have for you guys, that have been beekeepers for a while, I'm sure, have you probably noticed that there's a colony now and then in your apiary, and I'll find them on occasion, where they're extremely productive, much more productive than any other colony next to it in the apiary. And they seem to have a ton of bees, many more bees than the other colonies have near it. And the likelihood that that's a 2-queen colony is great. And we as beekeepers, lots of beekeepers, early beekeepers, backyard beekeepers especially, and new beekeepers, are always fixated on trying to find the queen. So, or some evidence of the queen. I try to discourage that in new beekeepers and saying, listen, if you see eggs, you don't have to go look any further for your queen. You're generally safe that you have a queen if you can find eggs. But most beekeepers, and me included, stop looking for queens after you find your first queen, and especially if the colony is loaded and loaded with bees. It's difficult enough to find the queen to begin with, and if you happen to spot her, and that's what you were looking for, evidence of a queen, then you can just close the colony. So there's lots of 2-queen colonies out there, and however they got that way, we don't know. Maybe, a swarm queen came back in the wrong colony, and she just happened to come back in during the flow, and they let her live there. But multiple queens do exist naturally in our honeybee colonies. And now the question is, well, if we know that, and Roger Hoppengarner was an expert at 2-queen colonies along with Ferrara and some of the early scientists, and he still lectures on them. The question was that you normally wanted to try to ask was, well, how can we make this happen? All right, so before we get into that, let's look a little bit on a single queen colony and the brood capacity of that. So let's take a look at this queen here, and she's laying eggs now. All right, so I'll ask a couple questions about this one. So here she is, laying eggs. She's got her abdomen in a colony, in a cell right now. Notice the retinue around her, licking her, carrying her pheromone to all other parts of the colony. She gets out of that. 'All right, 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 ' finds another cell. And lays another egg. There's a little rainstorm in the background of that video, which I like to listen to, actually. So anyway, before I forget, if there are any questions, I don't know who can control the chat, write them in the chat, ask them as we go. You know, makes it much more dynamic if we're discussing, you know, things that people don't understand or want more information on while I'm presenting. I'm not the kind of a presenter that cares if you interrupt me at all. So what did we just see? All right, we saw, I'm asking a question. It's about a 60-second video. It's a little bit longer, but how many eggs did she lay? I'm going to do this math for you based on what we saw. So it looks like it was about a minute, and I say she laid about a minute, about an egg and a half in that 1 minute. She wasn't completely finished, right, with the second egg. So if we look at that in terms of an hour, she'd be laying about 90 eggs per hour. And then in a 24-hour laying period, we'll give her the benefit of the doubt that she's laying prolifically and that she can lay about 2,000 eggs a day, a little over 2,000 eggs a day. All right, so in the height of a queen's fecundity, she's capable of being able to lay 2,000 eggs a day. It's probably much less than that on average, but let's give her that benefit of the doubt based on what we saw in this video. All right, so that establishes sort of a beginning point of where I'm going with this. All right, so let's follow me, just follow me for a minute on this. All right, oh, and I just wanted to say that, yeah, this is sort of a fun fact that, you know, queens can lay more than their physical weight per day in eggs. So that I thought was pretty incredible. She has to actually develop eggs in her ovarioles that weigh as much as her body, and that's about 150 grams or so, 50 milligrams. All right, so we're following this logic now about egg laying. So just bear with me. So if a queen, a single queen, can fill about 70%, well, typically, let's say that in a brood nest, a given frame is filled somewhere between 70 and 80% with brood. So turns out that a queen normally doesn't lay from wood to wood on eggs. Sometimes you see a frame that's that way, but for the most part, when a queen is in stride, there's a honey band, there's a food interface where there's usually pollen. In this case, the pollen's gone because all the brood is sealed, so there's probably brood in the rest of that area. There's some wet nectar on the bottom of that frame. So as a rule of thumb, when we consider a frame and the cells that are available for a queen to lay, we usually say it's about 70% filled with brood. All right, so we're going to continue with our little calculation here. So then I'm asking a few questions here that I'm going to answer. How many cells are on the sides of a Langstroth deep? So it turns out that a Langstroth deep frame has 9,000 cells. And then if you look, 70% of them would be where the queen would be typically lay. So on a Langstroth frame, in the brood area where the queen's laying, she probably utilizes somewhere around 6,300 cells. The rest of them are filled, as I said, with other things, right, to make to make a legitimate brood frame. So, and then the question is, well, when can it be used again? And that's the 21-day cycle. So I said approximately 20 days later, and of course that has to do with temperature and all of that. So somewhere between 19 and 21 days later, that cell can be used again. All right, so then if she's laying about over 2,000 eggs a day, in 20 days, which is the brood cycle. How many eggs will she lay during that 20-day brood cycle? That turns out to be 43,200 eggs. So then all of this all these calculations were to bring you to this one awareness that at 43,000 eggs in a 20-day period, if you divide that by the amount of open cells available on each frame, you get that the entire efforts of a really fecund queen can only lay about 7 frames of your brood box, and that's less than 1 deep. That's why, by the way, you see this trend toward single deep beekeeping, because a queen, even an extraordinary queen, can't fill more than 7 frames of brood. Now, keep in mind that next time you keep that in mind, and then next time you do your inspections in the next spring, remember this if you can, and then you'll see these 7 frames in there, or maybe 8. They don't have to be in one brood box. They can be split over 2, but they'll never be more than this. That's all you can get, right? So you can get about, so a single queen has that capacity. Now, if you had 2 queens in a colony, you could have double that capacity, but you can't get higher than that capacity with 1 queen. All right, so that's the fundamental principle of why a 2-queen colony will be much more prolific, have an incredibly large field force, and will make much more honey for you because you have 2 queens laying in the same box, and they act differently. Big colonies act differently. And I'll show you more about that. Their foraging habits are different. All right, so I'm going to introduce a little terminology here. One is 2 queens, and I call it a 2-queen system. This distinction is without much merit, and it'll fade fast when we begin to talk about the practical application of this. But so in the terminology, 2 queens is more than 1 laying queen, but they're separated with a queen excluder. So that's actually not a multiple queen system. A multiple queen system is when you have more than 1 laying queen in the same colony, with queens having access to each other. That's a distinctive difference, because if you have 2 queens in a stack and you have a queen excluder between them, granted, the nurse bees can move between the queen excluder, but when the brood and the queens are on the same frames and they're being mixed, there's a different phenomena that takes place. There's an incredible explosion in population. Now, a 2-queen colony, you will have much more workforce, but in a multiple queen system, that's the ultimate. And that's where you can strive for that if you wanted to try this at all. By the way, all of this is based on an article I wrote in Bee Culture, I don't know, back in 2016 maybe, and it's available to you. All you have to do is search my name, Bill Hesbach, 2-queen systems, and it'll come up. So it's had circulation for a number of years now, and I've talked about it for a while too. So it's popular. It's been vetted out. All right, so here's what I refer to as a vertical 2-queen system. Now, this happens to be in my apiary. And basically, I have, in this case, 2 queens separated by a queen excluder. So in the middle there, you can see that queen excluder right there. There's a queen-right colony down below. That's a super. And there's a queen-right colony above. Now, in this case, this particular colony may have made 250 pounds of honey that year. It was an extraordinary year. Oh, there it is. That's where that Bee Culture article is. February 2016, that's where the article is. 2 really productive queens separated by a queen excluder. Now you can see that this colony gets pretty difficult to manage, right? So, but I'll explain the manipulation that gets you to this point. in a little bit. But so that's an example of a vertical two queen system. There's also a horizontal two queen system. This is where you have not stacked them vertically, but you've put them side to side on a common landing board. And then you have a center divider. I'll show you more pictures of this later on. It'll become a little clearer how this actually works. There's a queen excluder in the middle here, right between these two half telescoping covers. And these two colonies have access to this super above, right? So both the queens are separated. So it's a two queen system. It's not a multiple queen system. It's a two queen system. And both colonies have access to the same super. So the theory here on these horizontal systems, two queen systems, is that they will build. You have two queens, two colonies, and only one place to store the honey. So they store it like crazy up there, and you make a lot more honey. What I've had happen to me in these horizontal systems, and this one was the one where I had it happen to me, is this colony on facing this photograph on the left side is very strong and built its honey up in just half of this super. All of the frames were available to them, but they just stopped building. And on this side, this colony was a little bit weaker and didn't build any honey at all in this side and stayed down here and plugged this frame out with honey. So a horizontal system is a great thing to look at. It's fun to build one. It's fun to run one, but they don't necessarily work the same as a vertical system. In a vertical system, you almost always get a really high production of honey. All right, so let's talk about uses for that multiple queen systems. And I mentioned that one already. Honey production, when multiple queens have unrestricted access, you can get lots of honey produced. They've historically been vertical. And swarm management, of course, you can use a Snellgrove board or a double screen to put this configuration together. And you can use artificial swarms with double screens and yard increases. So those are some of the things you can use multiple queen systems for. Basically, folks do it for increased honey production. And you can get a lot of honey on a successful multiple queen system. And I also want to stress the fact that you can just have some fun with it, because it's a lot of work because of that vertical stack, but you can have a lot of fun with it. So why is it that honey production is bigger with multiple queens? Because they have a large population of bees. And then this really interesting phenomenon occurs with large populations. And Danka, well-known bee researcher, still being, now this paper, he was the PI on this paper back in 1987, and he just published the paper last month. So he's still around doing all science. So, he set out to show in this paper that colonies with large populations devote a larger percentage of that population to foraging. Now that's an interesting concept. You got to think about, if you have a small colony that's 30,000 bees and you have a multiple colony that's 60,000 bees. In the multiple queen colony with 60,000 bees, a higher percentage of those bees in that colony will be foragers, right? So, and when you have a higher percentage of foragers, really interesting things happen, right? Large foraging populations process information more effectively. Now, I don't know the exact reason for that, and I don't think it's probably hormonal. And there's lots of going on with large populations. There's lots of brood coming on, so there's brood signals around. So there's lots of receiving bees that are collecting nectar and running it back to cells. So large populations process information better. And that's just a fact. So this is, of course, Mark Winston's work on and Eckert, which is like, this is, you know, all wonderful work to read if you have any interest in this stuff. And now, how did Denke figure out that there's a higher forager population in larger colonies? Well, here's what he did. You know, he took colonies and he manipulated them. So there were sizes, there was a smaller colony with a certain population of bees and a larger colony with a certain population of bees. You just have to know that, you know, he determined what is a smaller and a larger colony, and they were significantly smaller and larger. So there was some validity to his experiment. And then I'm not going to attempt to explain this particular contraption that he built, but just suffice to say that you have to have a lot of a mechanical engineering background to get this. But anyway, there's these tubes that he oiled, and he blocked all access to the colony except that the foragers would go through these oily tubes. And then when they landed on this device to come back in the colony, because it was their colony, they would slip into this mesh net. And he did this until the entire foraging population was caught in that net. And then he picked that net up, I guess killed the bees. I can't recall if he killed the bees or not, but then he went back and he counted them. And what he found out, that as a percentage of that the colonies, smaller colonies, as a donated, allocated these percentages. So in larger colonies, they usually looked at close to 10% of their population as foragers, smaller colonies, a little under 5%. So right away, there's a big difference between larger and smaller colonies. And this goes for any size colony, but of course, if you're going to apply this principle to multiple queen colonies, you can see how you get many more bees as foragers in that using multiple queens. So well, that's the trap he used. Kind of ingenious, I think. But anyway, found some other interesting things out. Well, this is Eckart's part. Eckart was doing all the timing. So in this large colony, he found that the trip times in large colonies were greater. So the time they stayed out, you know, on average, in the larger colonies, you can see it's 27.8. And he said, and then the trip frequency was greater in larger colonies, and the volume that the bees brought back was greater. Right. So here's that sort of natural, mysterious quality that large colonies bring toward their foraging. Right. So in this case, large colonies, you can deduce from this that large colonies stay out foraging longer, take more individual trips, and bring back more nectar. Now, if you want to produce honey, that's exactly what you want, right? Large colonies that will do those things. If you look at small colonies, they were significantly smaller. I mean, so, you know, it's not that you can't make honey with a small colony, you certainly can, but you can make a lot more with a large colony because of the biology that occurs to support large populations. All right. So one way that you can do this, now I'm going to talk about more of the sort of the practical side of setting up a multiple queen colony. And it's the best way is to migrate, in my opinion, from a 2-queen system to a multi-queen system. So how do you do that? Okay. So the best way to do this is with your large colonies that overwinter. So right away, if you have a large colony that comes into early spring and is sort of robust, and you're going to have to do some swarm control on that anyway, and you want to try this multiple queen deal, you can make a nice early April split and purchase a queen, California queen, or by April, we were actually able to get some queens here locally this year, in Connecticut at least, anyway, from my organization, from the Connecticut Queen Breeders Cooperative. you could have queens available and you could split out a nice split out of a nice robust colony, and I'll show you what you do with that. All right, and then it's less productive, but sometimes possible, is to get an early queen, an early package, and about 8 or 10 weeks before the flow. All right, so so you can start them with a package, but the most productive startup is with an early split out of a really robust colony. All right, so I'm gonna talk you through this. It's not so easy to talk this through. Usually when I give this presentation, I have equipment with me and I place the boxes in their order. So you're gonna have to try to visualize this. So you make a strong split over a wintered colony, place the split over the donor on a double screen. Now, do you know, if you don't know what a double screen is, I'll show you one on the next page. And then you introduce the new caged queen. And then about 2 weeks after the queen starts laying, you replace that double screen with a queen excluder. And when the flow starts, you remove the queen excluder. So that's the migration between two queen and multi-queen. All right, so here you go. We got a nice overwintered colony. There's a double screen. I'm going to show you that on the next page. So I think you've all seen these. And so it has a bunch of doors. It has 2 screens. There's no possible way for any bees to pass through a double screen board. These are also called Snellgrove boards. And there's a great little paper, the many uses of a Snellgrove board, that you can, that's actually referenced in that bee culture article, if you want to go back and look at it, that I wrote, and that you can read up on how to use double screens. There's plenty of ways to use them. I'm just using it in this way. All right, so then again, I'm going to just review this again. About 2 weeks after the queen starts laying, you replace that double screen with a queen excluder, which gives them access to each other. And then when the flow starts, you remove the queen excluder. So you can see that migration between 2 queen to multi-queen. All right, so let's go. Let's take a look at this stack. All right, so this is the initial 2 queen setup, right, that I just discussed. So you made this split. You have your donor colony below with the original queen. You have a queen excluder there, and I usually put 2 or 3 drawn comb supers right in here at this point. And I'll explain why in a minute. And then you have the double screen, and then the remaining brood with an introduced queen above it. Right, so everybody get that? You get that configuration? You have a queen in here that's new to this brood up there. She's not laying yet. Down below is all of your brood you left behind and your queen. You usually take most of that split out. Now, all the foragers, of course, as soon as you open up one of these doors, like this one is open here, all of the foragers that are in this top box fly out and they go back to the front entrance. So your bottom box usually ends up with a big field force. Your top box ends up with a lot of young and capped brood. You put a lot of aged brood up there too, because you want new bees right away, but you have to have some vacant comb up there for your new queen to lay. You check and make sure your new queen is released and that she's laying wonderfully. Then you remove that queen excluder, that double screen, excuse me, and you put a queen excluder in there. And then you have to be informed about your flow. So you have to back all of this up, make sure that you start this multiple queen colony about time so that you meet the flow when you're going to pull out your queen excluder, right? So you can't pull the queen excluder out before the flow comes, because if you do, you're likely to get into a fitness struggle between the queens. You're going to pull both queen excluders, by the way, at that time. So you're not going to have a queen excluder in a colony anywhere. All right. Where was I? Okay. So yeah. So you have to know when your flow is, because the flow is what distracts the queens. And if this is timed correctly and you remove those queen excluders right at the flow, the beginning of your main flow, and you probably all know when that is, right? The likelihood, about 90% of the time, both queens even though this is an introduced queen up here, the queen excluder that you had in here after she started laying gave a little bit of pheromonal balance to this vertical stack. And so they become familiar with each other's odor. And then the event of the flow distracts them to the extent that they will allow both queens to live. It's very seldom that they kill each other at that point, because the colony is way too occupied with putting up reserves. That's why, by the way, you put this stack of supers here. Right now, you may find that, these fill really quickly, and you might have to put a stack of supers above on the top. That's what you were basically seeing in that other first vertical stack I showed you. So I know this is a little complicated, but is it clear to folks at all what we're doing?
So far.
Okay.
So
All right.
Bill, what happens when the flow's over?
Oh, when the flow is over. Okay, so that's a good question. So when the flow is over, I've had these stay as a double queen colony all summer and over winter and come into the next season as a 2-queen colony. That's a possibility, but there's likely to be there can be a fitness contest that occurs after that point. But remember, at that point, you have 2 fecund queens. They're not in the mood to fight. And so they could possibly live on for a long period of time. But it won't matter much to you, because, you're going to harvest, you're going to let this thing run on however kind of configuration it wants to run on, single or double queen, after you've made all your honey and you harvest, right? So it won't matter to you, because you're going to get the benefit of having a colony that doesn't want to swarm and makes a lot of honey. And there's lots of principles, and let's talk about a few of them, which gets at your question a little bit. There's extra queen pheromone in the colony, which has a tendency to quell swarming. With that mandibular pheromone out of 2 sets of mandibles going like crazy, laying like crazy, and their pheromones being spread out throughout that whole colony, there's a sense of satisfaction among the rest of the bee population that everything is fine in that colony. There's no reason, and plenty of supers on it, plenty of room, there's no reason to swarm. All right, so as I've been trying to mention, or I'll just summarize that, a large population functions as a single biological unit, right? So, and these are all Hoppengartner's and my own observations, by the way. Nurse bees and house bees, they just mix together fine. Egg laying occurs at an increased level. And here's the interesting part, is the fecundity. And when I'm saying fecundity, I'm incorporating the queen's ovarial development, assuming that she was mated or raised well, fed well as a larva, and had lots of ovarial development. So sure, her ovarials are large. She has a lot of them. She's not a just an underprivileged queen. So, and she's had a sufficient mating. So she's mated with a significant amount of drones, right? Say 15 to 20, let's say. So she's both has the capability biologically, and she has the sperm available. That's fecundity. Fertility is sperm, right? Fecundity is the whole deal. Well, let's say you have 2 queens that, you're never going to get 2 queens that have the exact same fecundity. If you did, and it's going to be wonderful, say for instance, but it's averaged out. And so that's something that you want to check on, whether or not, you have a really weak queen that you've ended up with the multiple queen system. You'd want to probably do another manipulation in that colony. Can't introduce another queen, it would be too late. But that other queen wouldn't be doing much at that point, and you wouldn't really have the benefits of a multiple queen colony. But let's say you have 2 average queens, their fecundity is averaged out. So with one really fecund queen and one average one, you've got a nice mix of a little bit above average egg laying, right? So, and if they do make it into fall, and I hope you try this, one of your brave souls tries this, and if they stay multiple into form, you get better winter survival because you've got a lot of winter bees that come on late in the season, and all the natural stuff that occurs in the fall where bees are cast out, drones are cast out, bees die off like crazy, that also happens in a multiple queen system, except that they've laid a lot of brood late and there's no brood to care for. So you got a big, well-stocked set of winter bees. And if you've done your job of keeping them healthy all year with Varroa and all of that, you got a really high chance of winter survival. And before Varroa hit us, this was a piece of cake. All right, so there are some challenges. I don't want to make this all seem like it's wonderful and easy to do. It's hard for you to inspect during the 2 queen and multiple queen stages, but you have to do it. You don't have to do it all the time, but you do have to do it. But that's difficult to do. I'll show you what some of the old timers used to do with vertical stacks. I'm laughing because it just seems like something that's so counterintuitive, but they used to do this. I'll show you what they did. More bees lead to tedious inspections, more stings, of course. You're going to get, a lot more. It's hard with a lot of bees. I don't know if you guys have really robust colonies. This was a good year for robust colonies in my area. We had really high populations, 35, 40,000 bees, maybe even 50 in some colonies that were just single queen colonies. And if you lose a colony during that flow piece, you're likely, the bees, the colony's likely to swarm. It'll get into a situation where it's likely to swarm because you're losing that other element of pheromone. And it's mostly vertical and high. You need like a ladder to get up to the top. Now that when you get, I think you can clip, yeah. So when I'm running my cursor over that URL, I'm getting, it's blue on my page and it is on yours too, but you can run that, and it's a great thing to hear Hoopengarner give his 2 queen system talk. You can just visualize, it's only a talk, you can't see the, I was never able to find the slides he showed, but he's a great presenter and you can follow him really easily. It's about 15 minutes and he talks mostly about 2 queen systems. And he talks a little bit about Ferrara, you're going to see on the next slide, right? So, so Ferrara, who was a master at queen colony management, he he said that you can work them satisfactorily, and it justifies the increase in yield. Now, he says that you could smoke them, remove the telescoping cover. And then he says the hive can be supported on each side and tipped over backward and worked in a horizontal position. So now he means that. He means that they lay the whole 10 frames down on the ground, break apart the boxes, put them back together. And, he says the propolis will help them from slipping. And then he could say 9-story hives are lower to the ground. All right, so you get that? There they are, right? There's an old school apiary with that arrangement that Ferrara's talking about. Imagine doing that. Flipping them all down, work them horizontally, put them all back together and lift up the whole stack at once. I don't know, vertically challenged. Vertically challenging. So they get that way, right? But they don't have to get that high. All right, so Okay, so this is more or less what we've already covered a little bit of. I showed you about the snow growth board, and there's a little URL to the many uses of the snow growth board. It's really difficult to understand how important that snow growth board is in your beekeeping practice. And you can probably go look around in your junk piles in your garage or wherever you keep your bee equipment. You'll probably find one that you bought at a bee show somewhere, and then you said, Jesus, I'll never use this thing. But you pull it out, or a regular double screen, and get accustomed to it, because there's plenty of uses for it. And one, of course, is an artificial swarm. And you can use this and just establish it. I'm just going to talk, I'm off multiple screens now. I'm just going back a little bit, how you can use this double screen board for a 2-queen system during swarm season. And then this is how you do it. The same way I had it. Artificial swarm, you put the remaining brood up on top, and you catch a really robust colony early spring. This is swarm management, right? You let them make their own queen in this case. So it's a walk-away split, if you will. All the foragers, and you have to read a little bit about how to execute this. It's not as simple as this little diagram is showing you. You only leave the queen and 1 or 2 frames of brood in the bottom box, and you put all the brood up in the top box, and they're isolated enough between this snow growth board, this double screen board with the door open, that they will form swarm cells up there with that brood. And you have to, of course, have a great colony to do this with. And then they'll raise their own queen. And then you can run it like that. Or you can take the double screen off during the, if you happen, usually doesn't happen. This is too late for the main flow. Right? The flow's already on you at this point during swarm season. So this is not something you use like a migration from 2-queen to multiple queen. This is something that you just can use as a swarm prevention, not prevention, but manipulation. All right. And then, you have 2 queens, and then you can just combine them at the end of the flow. All right. So in a horizontal system, a horizontal system is really interesting, and I touched on it earlier. I'm going to show you some photographs of how it works. And now there's a needed improvement. And if you look at the way that this, and I'm talking about this bee-weight isolator. I'll talk about that in a minute, because it's just such an interesting thing that somebody developed way back in the day, and it never got made. But it was kind of interesting, and it solved this problem. Let me show you what's going on here. So you have, in a vertical system, free mixing of bees. But in a horizontal system, for these bees to mix, they would have to crawl over this separation, right? And get into the next box. Let me show you that. All right, so here how it is if you took off the super and you had just one side. So you have in here 5 frames on this side and 5 frames on this side that are not showing. But the bees have to come to this, all these top bars, go through this queen excluder, right, over here to get into this side. All right, so they just don't like to do that. They object to it. So they basically, in a horizontal system, they like to stay in their side. All right, so but I found that this was an interesting way to put drone comb in, because you could do lots of drone trapping up here. You can also treat these colonies, and I did with formic pads, by removing these 5 combs and then putting the formic pad down on the top bars of the bottom box, right? So you can actually go ahead and treat. So it doesn't keep you from treating, or it's a little bit difficult to inspect because you have to take off the super, and then you have to slide this queen excluder over or put a blanket over one side while you do your inspection on one side of the colony, and then then switch it over and do your inspection on the other side. It's a little bit more cumbersome. Two queen systems and multiple queen systems are in general a little bit harder to manipulate. Right, and then I just show this little custom-made half telescoping cover I made. You don't have to do that. You can put a piece of cardboard, a piece of plywood over the top of that or something like that. It works just fine. But I made these little half telescoping covers that keep the water off of the 5 frames that are sort of exposed on the end. Right? But this ingenious inventor came up with this device he called a bee a bee-way isolator. Now, my first engineering education was mechanical engineering, and I stared at these for a month, I think. This was Otis Pennell, and he did this in 1969, and all I had was these patent drawings, and I made one. Once I figured out what the hell he was trying to do here, and I can't even begin to explain this to you without you seeing the actual device that I made, and even if I held it up in front of the camera, it would confuse the shit out of you, I think. So what it does is the bee-way isolator, right, allows through these like little channels, it allows bees to move between, you put it here, the bee-way isolator goes right between these boxes, the lower and upper box on each side of the horizontal system. And the bees are allowed then to walk through and mingle at this level rather than have to go up and over to do it, right? Which they're not likely to do. But it looked, it's a wonderful little device. I labored like crazy and made one to its exact standards. I put it in the colony, and they looked at each other through the little passageways, but they wouldn't go over, and then they started to propolize the passageway shut. So, I'm not really sure that I could say that it worked, but it was ingenious, and it was, I wish it did work, because it was a wonderful way to solve the problem, to make a horizontal system operate more like a vertical stack where the bees can freely associate in here. And the device actually has a queen excluder built into it. So the queens couldn't pass between the boxes, only the workers could. So anyway, I thought that was interesting, and that somebody took it to that level of explanation. All right, so some considerations. You're going to have to know when your honey flows are. And I suggest that for every beekeeper, and I'm sure some of you do, that you begin a bloom calendar. I have one that goes way back. I didn't do it last year for some reason. I think this whole COVID thing got me mixed up a little bit, so I didn't do one. But I have bloom calendars in my area, which go back and record blooms for about 70 or 80 different plants that I have seen bees, honeybees, forage on in my foraging area. So I've recorded the pollen that comes back on from those plants, if there's any, and I've recorded the exact time. I have specimen plants I went back to year after year, and one of them got cut down. It was a beautiful black locust, but it got cut down. And I would record the date it bloomed, and then I would know exactly when my main flow was coming, because I know what plants in my area provide it. So I didn't have to worry too much. And if having a bloom calendar that is specific for your particular location really lowers your anxiety level every year about what's going to bloom. Because sometimes you do miss blooms. What's going to bloom and when are you going to have a good flow? You don't know if by the way, let me back up. You don't know if you're going to have a good flow, but you know when those plants are going to bloom. So now, where you live, of Cornell has a great site. You can see that reference there. Get on that site and you can see where Cornell will have information for you on degree days. And you can actually use, in my bloom calendar, I had a column that I started that has degree days next to it. Cornell has weather stations all over the Northeast here. I'm sure they have plenty of them around your area, especially around in Cambridge. I'm sure there's plenty of stuff over there. There's one less than 2 miles from my house, and I live in a rural area in Cheshire, Connecticut. So Cornell keeps all of this degree day data for orchards in the area because they're a land grant college, and that's part of their mission to help folks that are raising produce. So you can then insert Cornell's degree date. I don't know if you know what a growing degree day is. It's the amount of, there's a couple different ways that they're calculated, but the one that they use, it just measures the temperature of days. So there's like a 32-degree day, a growing degree day, and there's other versions of it. Some of you may be more familiar with this. And then so what orchards and fruit growers and the whole fruit bloom depends on is Cornell's data, because they have different bud stages that bloom with precision to the amount of degree days, the amount of temperature above a certain point that will allow the buds to bloom. All right, so silver maples, by the way, are the ones that bloom first, and they hardly need anything at all. Like three growing degree days is enough for a silver maple to bloom, or it'll bloom without that, I guess. But they're the first ones in my area, and they give bees a source of pollen and nectar. So it's great. So you can actually have this bloom calendar, and you can actually try to figure out with Cornell's information when your blooms that you're chasing around are going to finally bloom out, because those degree days are as relevant to your weeds that you're looking forward to, autumn olive and so on and so forth, dandelions and all of them. Degree days dictate when they bloom also. So you can make this happen for yourself is my point. All right, so that's about where I end with this one, unless we have some questions. And so this is sort of a philosophical statement. I wrote this a while back. There's my article again. You can look at horizontal two queen systems in bee culture. I wrote that in 2016, and I encourage you to think like this. Once you move your thinking out of hive centricity, being hive centric, into understanding that everything that you observe inside of a colony throughout the year is always moving forward based on the available resources in the ecosphere. The biology and the ecosphere are linked. They're not separate things. If the floral sources don't materialize, the biology stops. If the biology will never start without the floral sources being available, unless, of course, you artificially stimulate them in some way. All right, so that's where beekeeping becomes an art, when you move out of thinking of the colony as just a biological unit, but rather that it's yoked up to the ecosphere. All right, any questions? That's about it for me.
That's great.
Thank you, Bill.
Great talk, Bill.
Thank you.
Thank you.
Let me
So
just
I
stop.
have a number of questions.
Sure, let me stop this share. Go ahead.
Sure. So for supersedures, there's efficient supersedure, which in the multiple, with the Hymenoptera, the multiple queens, at least for honeybees,
Yeah.
when a mother and daughter are
Yeah.
coexist.
Yeah.
So your multiple system is sort of simulating that and taking advantage of that. even without the sort of matrilinear line. So if you introduce another a non-line or a totally different line, a queen from a different line. So, but it's still simulating that multi-queen in the same time space
Yes.
that a supersedure has. So that's utterly fascinating.
Yeah.
Uh,
And well, so so a supersedure is a natural occurrence of a like pheromone
mhm,
profile. You're forcing a like pheromone profile by moving from in those stages from two queen to multiple queen. By even in the first one, where there's a double screen between the colonies, you're getting pheromones to mix. And then when the queen excluder goes on after the top queen starts laying, the workers have full access to the top box where the new queen is, and they won't kill her. You know, they're not in the business of balling a queen, and because they've already been familiar with her. And then of course, sometime later, a week or two later, or 3 weeks later, when the flow starts, they're totally preoccupied with the flow, and they'll allow the two queens to live. And then you bound that colony into a pheromone profile that's a combination of the two queens. It's an interesting manipulation, and it works. You know, it can be done.
Excellent. So, and you're doing this all sort of beginning or prior to the flow. So
Yes.
they're not going to be raising that many drones. I had a question with the queen excluder, use of the queen excluder, if that's going to prevent any drones from sort of locking them into place, but there aren't going to be that many drones at all to start off with that time of year.
Yeah.
Um,
So drones are a problem in that top box.
yeah,
And they're a problem not when the door's open, not when double screens are on, because there's a door open they can fly out of.
right.
Once you take that double screen off and you put on a queen
Queen
excluder,
excluder.
they can't get out.
Right.
And you don't want to provide a top entrance.
Okay.
All right, at that point, right? So you don't want to do that if you can join it. And then what you end up with is I've had beekeepers come in to one of my classes that I teach with frames, and it looks like there's a bunch of drone heads on a queen excluder where what happens is they can't get through it, so they die on the queen excluder, and then the bees pull their bodies off, and their heads can't come through the queen excluder, so they're all rattling around in there like 100 drones got their heads cut off. But
Okay.
what I do is to help drones during that period, I'll lift the top telescoping cover off now and then, and they are ready to fly out of the colony. And they
Okay.
will. And then, of course, they can't get back in, so they come in through the bottom colony again. So
Okay.
I try to let them out. Now, you can make a drone escape. I've never done it, but you can make a drone escape. It's a smaller hole, but I just don't drill holes in my boxes, so I don't do it, but it can be done.
Okay. Excellent. So, once you remove the snow grove board, you replace it with the queen excluder.
Yeah.
Once you replace the queen excluder and you have the sort of free reign of the two queens,
Yeah.
what happens to the brood area? You start off with this two separate brood areas. Do they start to migrate? Do they merge into one area in the hive, or is there some separation? Because when you first put on the snow grove board, you have the two honey supers or the two
Yes.
drawn out.
Right.
So what happens to the brood area in that large vertical box?
All right. So when the flow occurs, I didn't cover this. Thanks for saying this, Tony. I missed covering this. You have like an option for a couple of manipulations. You can leave them separate like that.
Okay.
Then you're going to have a problem with the brood because the queen may stop laying in the first honey super, right? So that might happen. And the other thing that might happen is with single boxes. I don't know how many you folks run single boxes, but if you run single boxes, you'll notice that the colony is likely to store pollen in the first super above the box. You can let them do that. That would be
Mhm.
fine. But what I like to do is bring that top box all the way down to the bottom box, and then just have 2 brood boxes on top of each other. And then you can put a queen excluder on and run as many supers as you want on top of it.
Okay.
All right. So you can do it either way, but I prefer to merge them in a conventional sense. Have
Okay.
2 brood boxes and then the supers on top, because they will start to plug up cells with pollen in your honey super, because they don't have any place. If she's a really active queen down below, and she's been going like crazy, she won't have any place to lay. And she'll have plenty of places to lay, but they won't have a lot of places to store pollen. And if there's a big nectar pollen flow, they'll hoard pollen the same way as they hoard honey, and they'll put it in the super above it.
Okay. Fascinating.
I spin that. I produce honey, so I'm a honey producer. So when I find frames like that have some pollen in the bottom, I spin them out just like it's a regular honey frame. I cut the wax and spin them. I leave the pollen plugs in there. Some of them come out in the honey. When I spin the frame out, some of them stay in there, and it just puts more nice pollen in my honey.
Okay. Excellent. So, one of my questions was, could you go through quickly? You're down in Connecticut. We're up in
Yeah.
sort of Metro West Boston and up to the southern New Hampshire, and just wanted to get a general feel. I assume your flows are fairly similar to ours, where it starts sort of mid-April to end of April, and it goes to roughly July 4th or so. Um, and then we have a dearth, and then it starts up sometime mid to late August or September.
Mhm.
Um, I just want to get a feel for the timing that you're working with.
That's about exactly the same timing,
Okay.
except that we don't have. So all beekeeping is local. I mean, that's
Right.
a cliche.
Exactly. Which is why I bring up the question.
Yeah. So I don't want to. In my area, we have a bunch of sustainers that occur. One of them is dog bane. Dog bane blooms pretty much prolifically all the way through the summer. And I mean a lot. We have fields of dog bane. And that dog bane will maintain a colony, but we can get into a little dearth in July, like you can, but it normally picks right up again, because we'll have like a button bush come along, and some of those late summer or late July bloomers that will just give us a flow. So yeah, so we can get lucky here and not have a dearth. I've gone 5-6 years without a dearth, where bees
Wow.
are robbing each other, that kind of dearth.
Okay. Yeah.
Went really crazy. So all beekeeping is local. Sometimes we never get a pollen dearth. It goes from, I think some folks down on the shore of our state, where it's sort of arid, and they're in a different microclimate. I think they get a dearth like you get.
Okay. Okay.
Then of course,
Excellent.
around.
So Bernie has a question about whether there are more drones in the colony, and that sort of ties into my question, which is running the multiple queen systems. How does that affect your mite treatment regimen, especially with huge populations?
You got to do the
workers?
same thing you do. That's the biggest. See, if it wasn't for mites, these would be a whole lot more fun. But
Yeah.
I vaporize oxalic acid on a multiple queen system, so I don't have to take it apart.
Okay.
That's what I do for mite control. Now you still have to, and I monitor them with drop boards rather than get in there and do a bunch of rolls.
Okay.
Right. So where your normal management, is to roll. I try to gauge. It's not as accurate as rolling, but there are some sacrifices you have to make. And yes, is there more of a drone population? There's a higher drone population also, yeah, because you got 2 queens laying and you got 2 colonies that are about, but that they normalize. The good thing, if you start your bottom box with a drone comb, which I suggest you do, a green drone comb, and one in your top box and put a drone comb in there, you can actually get less drone buildup between your top and bottom bars.
Okay.
You know how that happens, right?
Yes. Yeah. Yeah. You give them some place to put it as opposed to
Yeah,
only using worker cells, and they'll put it wherever they can.
they'll put it wherever they can. And if you give them a place to put it, now, of course, you might want to think about culling that out of there, because
Yeah.
that's going to be a drone trap, right? So you can do that, or you can just give them that frame and then do your mite work the same way you normally do it, and leave them in there. Leave a healthy drone. A healthy drone population in a colony is good for it. And we cull them out, rip them out, and do all of that stuff. It's sort of a castration process that we're engaged in
Yeah.
our practice of beekeeping, and it's not good for the colony. It's not balanced. If you look at a top bar hive, and I ran I ran one with a swarm this year, which is beautiful little swarm, gorgeous little colony, never built more than 10 combs. But they set about building a drone comb. On the second thing they did was build a huge drone comb. So in a natural colony, as soon as you let them, they build drone, and a lot of it.
Yeah.
So anyway, go ahead. I got off the subject.
Excellent. That's the end of my questions. Everybody who's still online, do you have any questions for Bill? You can go ahead and unmute yourselves and ask away.
Yeah, I have a question on the horizontal version. Is that a unified bottom board?
Yeah.
Like it's all one?
Yeah. You know
piece?
what? You got to unify that, Bernie, because if you don't unify it, the colonies, you can't get them at the same level.
Yeah.
So I spent time making sure that bottom board was absolutely perfectly level. I put it on the bench and screwed 2 bottom boards together of the same make, and put 2 deeps on them, made sure that they, just so it works. That's all.
Yeah.
Otherwise, you'll get into big trouble, because you won't be able to get that queen excluder on top to be level. It won't work. So, and then the other thing, you can't use a wooden queen excluder up there. You have to use a metal one or a plastic one, a thin one. You can't have a lot of space, in other words, in there. A wooden framed queen excluder is what I meant to say.
Yeah.
So Bill, a question.
Yeah, Mike.
The Snellgrove board and pheromones, it was my understanding that the queen pheromone can't get through a Snellgrove board because there's no bee-to-bee contact. And supporting evidence of that is that if you do, I use a Snellgrove as swarm management in the spring.
Yeah.
If the queen pheromone would pass through it, then the top box would think they were queen right.
Right. Yes. So, but there is volatile organic compounds that begin to migrate between the colonies. So what you're saying is absolutely true, Mike. I agree with it. The time when you're really doing your bonding of your colonies is when you move your Snellgrove board off and you put the queen excluder on. At that point, you're going to get nurse bees that come up and carry queen pheromone up with them, and also bring queen pheromone down. So yeah, so there is contact when you do that. That's where the strong bond occurs. But if you look at Snellgrove's work, he had some interesting theories about how that occurs. Now, so there is some kind of bonding that occurs with just the Snellgrove board, but in all cases, and I think what you're saying is the same way I use them. I run a few every year just so that, because they're so much fun. But if the queen pheromone did get through, right, a Snellgrove board, then they're not likely to make a queen up top, but almost 100% of the time, they'll draw queen cells out. Now, there's another thing about footprint odor on queens. There's some theories out there, and I've read some science that supports the fact that the reason why swarm cells are built on the edge of frames is because the queen's footprint pheromone can't get down to that, or doesn't get down to there much, because in a big populous colony, she's usually in the center of frames laying eggs. And so the same thing can even happen in a colony with no separation. So that's why I think there's one theory that supports that's why queen cells are built down on the bottom. They're also built all over the place, though. I mean, but they're primarily down on the bottom.
Yeah, in my experience, they're the bottom of the top box. And
Yeah, the bottom of the top box, right?
the explanation I've heard is that that's the warmest place.
Well, because you got to draw a lot of wax out to build a queen cell, and you need heat for that. So you can't wax manipulation occurs, when wax glands are available, and also that there's plenty of heat. And if you look at the way Europeans practice beekeeping, they just flip that top box up and look for queen cells. They don't look anyplace else. If they don't see queen cells there, they put the box back together and go on. But if they see queen cells there, then they take action. They either scrape them, they do something.
Yeah. And the thing I've worried about too is that if you're interested in preserving some of the queen cells, the minute you pull a frame out and it's hanging below the bottom bar and you put it back in, you risk beating it up, which means the swarm cell you just tried to protect is now damaged.
You smash it.
Yeah.
Right. So how do you prevent that?
One time I put in I call it a shim, but it's a
It's a shim.
rim board.
Yeah.
I tipped the box up and there were all these queen cells, and I ran and got the shim and put it in and tipped it back.
Oh, you're not talking about moving them. You're talking about in the same box.
Well,
when you just put it back down.
the problem is the same whether
Yes.
you pull the frame or whether you put the box back down. It's
Yeah. Okay, I know. So then they're gonna load that up with Burcombe when you did that. I'm sure that happened. I thought you were talking about moving swarm cells out because you're gonna make splits or something. So what I do there is I put they used to make bottom boards that had a summer and winter side. They had a 3/8 and a 3/4 inch. So I run mine on the 3/8 side, and so I flip. If I'm going to put them into a nuke or a single box to make a split, and my swarm cells are hanging off the bottom frame, I just make sure I flip that bottom board to the 3/4 inch side, and I almost always have plenty of room for that cell. But I know what you're talking about. But I don't think that I run into much of a problem. I usually put them back down without breaking a lot of the swarm cells, or maybe I break a few I don't even know about. But there's always a lot of swarm cells that are up a little bit higher that will make it anyway.
yeah. Yeah. Thank you.
Yeah.
Excellent.
Cool.
Well, thank you, Bill. Amelie, Victor, do you have any questions for Bill? Otherwise, we'll let him go. This has been a tremendous lecture. This is just, I've learned a lot, and looking forward to trying this out next year.
Yeah. So, my actual preference is to always give talks live, and I'm not sure I'm even though I've given 20 of these over the last 9 months, I'm not sure I'm used to them yet. They're difficult, but it's a much more dynamic talk, all of them, if you can hear them live. So sometime next year, if we have an opportunity to break from this cage we're in, I'd be glad to come up and give you guys a talk if and meet you.
Yeah, that would be great.
Yeah.
Hopefully this will break by late spring, summer, and if we could set up a workshop of
that
some
would be
sort and have you come up, that would be great.
Yeah, that would be great. Cool.
Maybe you can bring that special board that you made. I looked at
You
that.
gotta see that thing. I mean, I spent half my life thinking about how to make it, and then I made it in a shop, you get the principle of what he was trying
Yeah.
to do,
Yeah, I build all kinds of things, and I'm looking at that. I'm like,
How do you
I'm gonna
make
have
that?
to- Yeah.
Well, it's a bunch of, it's ramps. So the first thing you have to realize is it's not a straight board, it's a ramp that the bees have to climb up. And then there's a little place where they go between. You have to see it. I brought that to a couple of talks. I brought it up to Saba, and I gave that 2-queen talk up in Saba, and I had it with me. And I'll never forget, guys and beekeepers, women, guys, they had their heads stuck in that box trying to figure out how it works. And it's just even when you see it, it's not intuitive. You have to have it explained to you. But anyway,
Excellent.
cool.
Well, thank you very much, Bill.
All right.
Had a great time,
Yep.
and
It was a pleasure to meet you guys.
yeah.
And give these talks.
We'll definitely be in touch.
Read my article. ABJ just came out on viruses, and not on viruses, on RNAi. It's on the front cover. I don't know if you get ABJ or not. I wrote an article on RNAi and the promise of healthy bees. It's an article about genetic manipulation of bees to make them healthier. So hopefully you can.
I read that
cool.
today, Bill, and I
All
was astounded that you could talk one week about how honeybees couldn't fly until 2005. And then 2 weeks later, read an article about RNAi.
Did you read it?
I did.
Okay, great. I mean, and I got some good feedback from that already. Like people, it's a difficult subject, but people, I think, got something out of what I wrote. So,
Excellent. I look forward to getting it in my mailbox.
All right, cool.
Okay.
See you
Thank you,
guys.
everyone. Have a good night.
Thank you and
See you
good
later.
night.
Yep, bye.
All right. Thank you.